As you have seen before in many chase scenes, characters in movies seem to make incredible leaps and jumps in order to either get away from a subject or follow one in a heated pursuit.
In the movie Quantum of Solace, Daniel Craig or James Bond makes several incredible jumps across rooftops in Siena, Italy. But the question is, are these jumps possible?
One jump that we will be looking at is where the hero spy James Bond slips down a roof and jumps across a gap safely to a balcony. It doesn't seem likely that anybody could make that jump while sliding down the roof like he did.
After using some video analysis, pixel comparison, and other mechanics, we were able to determine that the gap was about 4.7 meters wide, the drop was about 2.4 meters, he leaves the roof at a speed of 6 meters a second, and he jumps at an angle of 35 degrees. With all these factors considered, do you think that our hero can make the jump? Here we will be using 2D kinematics. We are close to the Earth, so gravity is 9.8 meters per second squared. We will define a coordinate system as so, and the equations we will be using are delta dy, which is the vertical distance, is initial velocity times the change in time plus half acceleration times time squared. And delta dx, which is the horizontal distance, which is the speed in the x direction times a change in time. We are assuming that the spy clears the gap in the x direction, and we are just looking at how far downwards he's moving in the y direction.
Given values are delta x is 4.7 meters, theta is 15 degrees,
The initial velocity is 6 meters per second,
and gravity is 9.8 meters per second squared.
We are trying to find the value for delta y. If it is less than 2.4 meters, then he makes the jump.
First, we need to convert the angled speed into x and y components. Using basic trigonometry, we can say that the x component of the spy's speed is vi cosine theta, and the y component is vi sine theta.
Next, we have to figure out how long it takes for Bond to get across the gap. To find this out, we used a formula and plug in the necessary x distance to travel and the x component of speed. Finally, we plug everything into the equation. Initial velocity here is the y component of speed since we are finding the actual distance traveled downwards. Acceleration is gravity, and since it is pulling downwards, it is negative. Initial velocity sine theta and initial velocity cosine theta simplify to tangent theta.
Plug in all the values, do the math, and you'll arrive at the answer.
Since the distance in the y direction is less than 2.4 meters, Bond does actually make the jump and lives to continue the chase.